Okay, let's look at some of the problems that you might see on test number 2. So this first one says to divide. When you have one term at the bottom, what you can do is you can actually write that term under both of the numerators, so you can separate them like this. And so now after you separate these, you can just simply cancel. So I can see that 3 will go into 9 3 times. 1p will go into the 8, so take away 1 there. 3 will go into the 12 4 times, and then we take away a p there. And so we end up with 3p to the 7th plus 4p to the 4th. All right, the next one, find the quotient and simplify. Remember that when you divide, you want to flip. So 9x plus 20 over x minus 8. You want to flip this and then multiply. So the x minus 8 goes on the top. And then you have x squared plus 3x minus 4. So nicely that cross cancels. Now, whenever you're going to want to factor these, and what's kind of cool in math, I guess I should say, you know there's probably going to be a factor that cancels, so that might help you with the factoring. This one I find a little easier to factor because all the signs are positive. X squared, of course, is x times x. I think of 20 as 4 times 5, and the reason that I think of that is 4 plus 5 gives me that 9. So I factored that. Here I know x squared is x times x. So now I just have to figure out how to factor this last term. Should it be 4 times 1 or 2 times 2? And I am going to guess that it's going to be 4 and 1 because, as I mentioned, most of the time you're going to have something that's going to cancel a factor. So I'm going to put a 4 here and a 1. The middle is positive, so the larger number has to be positive. And so then 4 minus 1 would give me that 3. That cancels, and leaves me with my final answer of x plus 5 over x minus 1. All right, multiply. This is just foiling. So a times a is a squared. Then the outer, so that was the first. Now the outside, minus 2a. The inside, plus 6a. And then the last, 6 times negative 2, negative 12. Combine like terms, so I have a squared. Negative 2 plus 6 would be a positive 4, and then with that a, and then minus 12. Sorry, I forgot to box my answers. All right, what do we have next? It says factor the trinomial completely. Now, once again, some of these are hard, hard to factor when that's not a 1, right? Because up here, the x squared, we know it's x times x. However, anytime you see something this large and this value's large, I'm going to guess, so I do the kind of the guess and check, that I'm going to use 26 times 1. And the reason why is in my brain, I'm going, wait, 9 and 26, that would actually give me 35. This is positive. This is negative, so I know it has to be a negative times a negative, so 9 and 1. And then you could FOIL it out to check it. Once again, you're checking really that middle term, and I can see when I add negative 26 and negative 9, that will give me that negative 35. All right, next we're going to factor this binomial here. And so what I can see with this is this is actually, that's a perfect square and that's a perfect square. But the other thing that I noticed, both of these have x's in them. So let's factor out an x first. And so that leaves me with 16y squared minus 49. Both of these are perfect squares. Remember what we mean by a perfect square: 4 times 4 and 7 times 7. So this is that special factoring that I can factor 4, and even the y is a perfect square, right? Y times y, 4y plus 7 and 4y minus 7. All right, so let's use the product rule to simplify this expression. So what you're doing is you're multiplying the numbers, and then you're multiplying the, I'm just going to put this inside here, the variables. So n to the 7th and n squared. So the numbers are pretty easy, right? That's negative 35. When you multiply with the same base, and what I'm calling a base is the big number, or in this case, the variable. When you multiply with the same base, you add the exponents. And remember, it's understood that there's a 1 there. So this would be m to the 6th and then n to the 9th, and that's it. We're going to multiply this out. We definitely want to factor it. If you watched earlier where I did a division one where I said, I can guarantee you there are going to be factors that are going to cancel. So I kind of just start doing this. Because I know all of these trinomials I am going to factor into binomials and hope a whole bunch of stuff cancels. So this one is x times x. I see 80 and I think of 10 times 8. Why do I think of 10 times 8? Because when I add that, I get this middle. So 10 and 8 plus everything's positive. Now these get a little bit harder because of the signs. Well, I know this one is going to be x times x. And then I think of 21 as 3 times 7. And again, the reason why is because 7 minus 3 would give me 4. So 7 and 3. 1 has to be negative. Since this is negative, the one that is positive has to be the larger term, because when you check this, 7, positive 7, and then minus 3. All right, this next one here, x and x. This is a little easier because there is only one way to get a 3. 3 times 1. I see the middle term is negative, so the larger value has to be negative. The other one has to be positive to get this negative. This one right here, I have x times x. And then I look at my 20 and I think of 2 times 10. I mean, I'm thinking ahead of what could I add or subtract to get that middle value. And so 10 minus 2. So I'm going to have a 10 and a 2. I see this is positive, so that's going to be positive. But if you noticed, I kind of knew that was going to be x plus 10. You know why? Because of that one. So when you're factoring, like factor the easy ones, I think the first one was probably the easier one, and then start looking at things that could cancel. And so it looks like I have an x plus 8, an x plus 1, an x plus 7, an x minus 2, and those, nothing else will cancel. So x plus 8, x plus 1, all over x plus 7, and x minus 2, and that is my final answer. All right, the next one is just simply looking at common terms, and the only thing you have to be careful of is that negative sign outside the parentheses has to distribute to everything inside the parentheses. So that's going to become a negative 6x squared. A negative and a negative becomes a positive 6x, and then a negative 5. And now I'm kind of home free. I'm just collecting like terms. So that's going to be what, negative 5x squared, because remember it's understood there's a 1 there. Let's look at the x's. So that's what, 10x. and then a minus 5 plus 4 would be a minus 1. So I think the only thing difficult really about that is don't forget to distribute that negative sign. All right, next, use the product rule to simplify the radical. So what we're looking at is this 90. And I want to pull something out that's going to be a perfect square. How about 9? Right? So I could rewrite this as the square root of 9 times 10. And I can even rewrite that as this product rule as 3 times the square root of 9 times the square root of 10. Well, the square root of 9 is 3. Can't do anything more with the square root of 10. And so I get 9 square roots of 10. All right, the last one I'm going to do in this video is another radical here. So I'm looking at the number 8 times 8. Okay, so I know I can take an 8 out. There's a little trick here because remember you're taking 2 of these out, and if you just wrote 17 down, you would take 16 of them out, right? There would be 16 would be an even number. You're always looking at the even number. Well, the easier thing to do is divide it by 2. Since you're taking them out, one of them out by 2s, and I can see that gives me 8 with a remainder of 1. So I am going to have a to the 8 with a remainder of 1a.